What's up, guys? Today we're going to be doing some GCSE further maths level trig stuff, just helping on this topic, as it's quite a short topic, but it also has some of the most difficult questions that you can find on the papers, and it does always come up, trig identity question. So we're going to get started. So firstly, we're just going to look at some normal higher GCSE trig that you have to understand to be able to get used to the further math stuff. So we have SOHCAHTOA. If you don't know how to do this, then you shouldn't really be here. So next we have half A B sine C. This is another classic rule that you get on your formula sheet. Cosine rule, also get it on the formula sheet. Same with sine rule. You should know how to use all of these. And lastly, we have exact trig with the table that we use here, with the roots going up in the fraction. You might not have seen this before. This is how I remember it. Next, we have the first bit of further math stuff. So that was kind of just a recap. Now we're going into the further math stuff. So we're going to be finding other solutions to trig equations. And what I mean by that is stuff like this. So sine of any angle will equal sine of 180 minus that angle. So again, sine 130 equals sine 150. They both equal a half. And you can think about the graph for that one. Next, we have sine graphs repeat every 360 degrees, which means that stuff like sine 30 equals sine 390. Next, we're going to go on to cos and say that cos is cos 360 minus x, again because of the graph. So cos 30 would equal cos 330. And we have the same repeat rule for sine and cos, where they repeat every 360. For tan, it's a lot more straightforward. It's just tan plus 180 plus 1. You just add 180 and it keeps going. There's no other rule. For tan, you just keep adding 180 and it's the same. Right. Next, we're just going to go over trig ratios. Trig ratios is kind of just something you have to do in further maths. It doesn't really relate to anything else. But if you see a trig ratios question, the only thing that's going to be there is trig ratios. There's not going to be anything else in that question you have to do. So it would be a question like this. So sine x equals 3 over 5, and it's obtuse. The fact is obtuse is important. And you have to find cos of x, and this would be on a non-calculator paper. So firstly, we know that sine is opposite over hypotenuse, simple stuff. Then we're going to draw out the triangle like this, so with the angle and then the two sides that we have right here, the 3 and the 5. Next, we're going to use Pythagoras to find the other side. So this is a Pythagorean triple, so it means that this side will be a whole number. Next, we know that cos x equals adjacent over hypotenuse, which means that cos of x would be 4/5. That would be the initial value, but we don't actually know if it's positive or negative yet, because what we need to do now is we need to use the cos graph. So if we draw it out, we know that it's obtuse. So from 90 to 180, that's obtuse, and you can see that it is negative for the entirety of the obtuse period of the wave here, which means that the answer is going to be negative, because for the entire duration from 90 to 180, it is negative. So cos x equals negative 4 over 5. So this is literally, there's nothing more difficult than this that will come up. Sometimes it will require you to sketch the graph at the start as well, if it's tan and reflex specifically. But usually it would just be something like this. Alright, next, this is the main reason why I made the video for identities. So you shouldn't really be struggling with what the identities are. You should remember what they are. It's just using them, and using them in questions like this is difficult. I've just taken the hardest trig identities question I found, and we're just going to throw ourselves into it and just try and understand how these questions work. Now, before we start the question, I want everyone that's watching to notice that out of like 10 steps in this question, only 2 of them involve actually using the identities up here. It's mostly just stuff related to factorizing, algebraic fractions and stuff like that. So when you see a question like this, you should not be scared about it. So the first thing we're going to do is turn the tan into sine over cos. So as you see, we've literally just turned it into sine over cos, but dividing by it. Next, we're going to flip it. We're going to flip it and turn multiplication. This is just normal dividing fraction stuff. All right, next we're going to move cos onto the numerator, and we're going to move this 2 sine x plus cos x onto the numerator, and get this fraction here. This is still saying the same. Next, we're going to expand the cos x like this. All right, so next we're going to do our second identity, and we're going to turn the cos squared x into 1 minus sine squared x. That's what we need to do here. And then, as you can see here, there's a +1 here, which is stopping us from factorizing. However, there's a -1 right here. So what we can do is we can just take away 1, because the denominators are both the same, we can combine these fractions and cancel out the 1s. So now we're just left with this. Next, we're going to factorize sine out. And now it's pretty obvious what you have to do. You just cancel both sine x's out, and that is your answer right there. So I appreciate that is a very difficult question, especially for 4 marks, but if you can just understand a bit of the process there on how to do it, you could do the average trig identity question that isn't as difficult as this is like the second to last question and by far the most difficult question on this paper. Right, thanks for watching. I hope you understand identity a bit better now, or just trig in general. A bit of a shorter video. I'll go through a paper next time. We'll go through probably 2018 or something like that. But anyway, I'll see you next time.